Awesome. Cool. I think we can get this. I think we can get the party started. Thanks, everybody. Thanks for the folks online. I think we've got a few folks online as well. We got 5. Looks like 5. Good. 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 Yeah, thanks so much for coming to the May 2023 meetup. Again, it's so exciting to have everybody meeting in person again. I mean, COVID kind of sucked. I'm not telling you anything you don't already know, but I'm just so happy to have everybody back meeting in person. So we've got a good lineup. We got Progressive with a daily actionable intelligence for operations in near real time. Next is a Confluent with a data mesh with Kafka, and then I'm doing a talk that's an extension of an ACM post I did last year, why there's so many programming languages. This is a last-minute change. The third speaker had a family emergency, had to back out last week. It happens, so I'm doing this talk. Fortunately, it was the same talk I had done a couple of weeks ago at a college, so I had one in my back pocket. Got some good timing there. So some of the standard announcements. So friend of the show. So if anyone is interested in speaking, again, I'm always looking for new talent. So if you do a talk for the meetup, you get the honorific friend of the show. It is yours to keep. It's yours for life. It's like a life peerage. You can't sell it or gift it, but it stays with you forever. So if you have an interest in doing that, let me know. Or if you just have topics that you would like to see, hit me up, and again, we'll try to find someone to address them. The July meetup is going to be at John Carroll, so we'll working on that agenda. So some quick announcements. So the Ohio North Database training group asked me to promote this. Unfortunately, they had an event that was just last weekend. That was a SQL Server on Azure event, but they asked me to put the word out for that. And Progressive has 2 recruiting shout-outs, one for an IT application security position, a senior or lead cyber engineer, as well as also a Kafka SME. So we have any other pointers on who to contact to? So Dan Pointer was the first person. Larry, where are you? He was here somewhere. So talk with Larry from Progressive here if you're interested in the Kafka position, or Jeff. So any other recruiting shout-outs while we're here?
Dealer Tire, we're looking for a couple database reliability engineers.
So for those that are online, Dealer Tire looking for some database reliability engineers. And was there another one?
Confluent's always looking for Kafka architects.
Kafka
Field architects.
Kafka, Confluent is looking for Kafka field architects. Cool, thank you. And also, thanks. So thanks for Progressive for the pizza, Progressive for hosting the meetup. We literally could not do this without you. There is some Confluent and Kafka swag out there in the lobby, and so Confluent swag out there in the lobby.
Pizza.
And was it Progressive pick up the pizza or was it Kafka? Oh, Confluent. Oh God, that was embarrassing. I'm gonna fix that right now.
We just both tables.
There we go. So thanks to Confluent for the pizza, Progressive for hosting the meetup, and again, thanks to Linux Foundation. We're using their Zoom to help get the word out to remote attendees, as well as also post the recordings online on the Linux Foundation YouTube account. And as always, the Cleveland Big Data members, again, we could not do this without you. So thank you for coming. Thank you for spreading the word. And with that, let's get into the first talk. Where's my Progressive speaker?
Yeah.
Awesome. And you need one of these guys?
Yeah, I'm good to go. Got to get into the Zoom meeting and share, so one moment, please.
And whenever you're ready, just click that timer. Look at the kitchen timer.
Where's the Zoom?
Please. I think I would have been more prepared.
You guys see what's all right? Hi.
Just in time. No, I had to wait for that beat,
so I take all this time and use the best of everyone's time here tonight. And thanks for having me. My name is John Moore. I'm a domain architect with Progressive Insurance. My domain is enterprise monitoring. Chat with me afterwards. I can tell you all about it. But that's not why I'm here today. I'm here today to talk about how we take a lot of data and try to take actions out of it. And it's the trying is it's an ongoing, perpetual thing that we do. And it's really exciting. But it started with a journey for me. I've been in this world of IT for 19 years. Started in operations. From operations, late nights eating all kinds of pizza, all the Mountain Dew you can imagine. And oh man, I'll start over. All right, sorry about that. Sorry for everyone remote. That was probably really annoying for you. But we'll keep on going. So my story started in operations. Again, late nights, keeping things up, making the lights go on, and responding to systems when they broke. Customers calling in and taking those first actions, and working under the toil of tickets and event management, and it was painful. But that taught me a lot. It taught me to become an engineer, think a little bit differently. It taught me to understand that data was really my friend. It wasn't about responding and just working under that toil, but how do you use it? How do you apply it? How do you get insights out of it? How do you take 10 things into one, 100 into two, 1,000 into 3, and start to drive correlations, drive the actions that really take you to the next level? That journey put me into another company, another insurance company for a short time, came back over to Progressive, came back over, went from that engineering into architect, product owner for a short time, and back now as an architect. But I think like as we look at those journeys, all those experiences build up onto something, right? So we think about this talk tonight about a lot of data. It doesn't start with 66 billion events in a day, right? It starts with one. And it starts with all of your own first experience and like moments with data. And I think of my own almost like these fence posts. So I do this conversation a lot when I think of my career as like those big markers in time. One of them for me was kind of seeing those reports and doing them manually and wanting to do something different, kind of free myself from that toil of taking information, doing my own processing, and then reporting it back out to somebody else. And those things that connect the fence posts, the broken fences, the crooked ones, as you drive through the country, you might have seen some of these things. It's like the real-time data event in my life. So those late nights and you learn and you do things, it's that constant stream. And some nights there's not much going on. Other nights there's a lot happening, or other days and weeks, and they all build up and they build up and you put a post down and you keep on going. And to get to using data effectively, I think you have to go back and think about those moments. You have to pause for a minute and reflect back as to what your experiences were. Where were things hard for you, especially in technology? This isn't easy work. For those that have been in this space for any amount of time, it's super interesting. Like the maker in us, the curiosity ones in us, there's always more to learn. but it's not easy. And I think we have to look back and see where could we have gone differently? What were those things that informed us on those next steps in our own decisioning? And that really takes us into driving that action. So as we look back, there's these ideas of what you used to know and then applying it moving forward. And when I look at driving action and how to do it, right, my customers come to me and say, John, we need to have tickets. John, I need this notification. John, can we make this report? What's the right thing to do here? How do we search for this information? There's a lot of hows in those statements, a lot of assumptions being made, and we don't stop to understand the why. So before we start to take action with all this data, we really need to know, why does someone want to take action with that data? What are they trying to solve for? Because not all data platforms are created equally. Not all things are, if you're with Progressive, right, not everything's Splunk. Sorry, I'll say that live on camera right now. It's not the answer to everything. It's amazing for real-time analytics, and we can talk more about that later. But if that's not what you need, let's think about what you're trying to solve for. Maybe it's a once-a-week report. Where do you get the data? Where does it live? How do you get to it? Start to learn and understand that, and then you can start to think about driving some intelligence out of this array of data. So we're going to walk through a really simple equation. Go back into your system engineer, developer minds and think about an application you wrote. And you have an app. It's beautiful. It works great on your computer, right? We've all tested our own code, and it looks amazing when I run it locally. But then I want to put it in a data center. That's a different environment, right? There's heating, cooling. There's a whole bunch of stuff that goes into that building. I need a computer. Apps don't just run, right? There's some compute that does that. And my customer wanted it to be a reliable system, so I gave them 2. But then we also wanted to make sure we had capacity for those bursts, and now I got to put a load balancer in here. All right, check, 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 check. Oh, wait, there's a customer. What are they going to do? What button are they going to click? Where are they going to go on that site? How are they going to interact with it? I didn't intend for that outcome. That customer has to talk to this application. Right? We have to have the network in there. Probably firewalls are going to be a part of that, switching, routing, DNS. There's a whole bunch of things. We're not going to get into that tonight. Network storage. Things have to exist somewhere. Database, yeah, I want one of those. Probably should be reliable, so let's go do some HA on that as well. Maybe we have always on replication. All those things as you think about it, every one of those boxes plus an array more, all creating data. Right? That application is writing out logs. There's a web service running on it. There's security logs. There's firewalls. There's proxies. There's all these things and all this data coming out of our systems at all the time. What are they telling us? How do we understand what that action is, and how do we start to drive any type of action out of it? So we think about our application. We need to know why. Why do we want to get to this data, right? Well, my customers need to complete that transaction. Oh, whoa, I went to the end. That wasn't supposed to happen. Don't hit the end key. Presenters, if you have an end key on your, it's by the arrows, don't hit it. New feature releases, right? A/B testing. I put this new feature out. I want to see if it actually made a change. My customer is working more efficiently. How are you going to figure that one out? Do you want to know when your hardware fails? Power supplies, compute, CPU, memory. What about forecasting? Do we have those problems to solve for? That unanticipated marketing campaign that drove traffic up into your website? Reporting, there's always going to be a report. Everyone's report. Pretty pictures, right? Who likes pretty pictures? I do. Make it clean, make a bar chart, show one number bigger than the other. It's going to be exciting. Compliance. So in the world of information technology and financial services, if anyone is in that space, compliance is a thing. It is a big thing. Cloud migrations, what? Looks like a data center application, but what if you wanted to move to the cloud? I was talking to someone earlier, right? Just like our vendors, and they've all gone on those journeys of how do you move some software I used to run in my data center to a cloud service? How do you know it's going to work? Those are some of the whys I find that people really want to get their data into a data platform and want to start to search it and want to start to get that real-time nature out of it. There's more, there's many more, but in the time we don't have to go over that. And I want us all to kind of leave today in this talk and just thinking that operational data, like that's the missing link. So when we think of a data environment, ecosystem, platform, lake, lakehouse, whatever we want to call this thing of data we want to call it, don't underestimate your operational data. One of my favorite use cases is just how operational data, we have to keep IP address management. right? E911 tells me I have to know where you are when you pick up the phone and call 911. In this building, there's access points, right? We authenticate to them if you're a Progressive employee, so they know that John's here, he's trusted, could be on the network. What happens if you put all these operational data points together? You can start to figure out where people are using facilities after a pandemic. Where do we need to make investments in the real estate? Where do we need to change? How are people working? What departments are in that space? I'm a leader and I want to bring people back into the office. Well, now I can say how many people are there. Layer in other types of data that you have on top of it, right? Your HR systems, right? There's a whole array. There's configuration management data. There's employee data. I can start to identify what's happening, what departments are using where and how. And then if you think about from the operational side, what systems are being used. How to know which ones you want to make investments into. This data all exists. Our systems are telling us that every day. And that is a piece, if we're not looking at it and not looking at it with the other arrays of data that we have, we're missing something. So how do we do it? We look at a lot of data. Why do we do it? Because we want to know more things. But what is it that we're actually doing? I haven't really talked about that. If anyone's picked up books on observability, it's this big craze in I&O, and you might hear about data observability. It's a classification, but that observability idea of understanding the unknown, right? How do you know the observability of a system? It's a quality. And there's certain types of data that help you understand that. Here I use this metric, and you can read about it and find out 3 pillars of observability. They don't include events, but it makes the melt actually something you can remember with metrics, events, logs, and traces. If we look at all of our systems, I talked about a few, they're all creating those things. And with a few additional steps, we can think of things like tracing. There's a whole framework of open telemetry out there that you can put into your applications and start getting GUIDs on top of things, and you can stitch the whole thing together. You have microservices you can see from A to B to Z. It's a beautiful thing, and that's the type of data we're talking about. That's the data that when you use it with the other information that you're getting, you can start to really refine that 66 billion number into 1 billion, into 100,000. And it's interesting when you start to look at it. I gave the one example, but what happens when you start to map different types of data together? You stop looking at it from your silo or your vacuum. You know, I'm just the SM team. I just support this application. But where are people accessing your application from? Maybe your defaulted time zone is Eastern Standard Time, but everyone's over on Pacific Standard Time. Maybe you should make a change. Right? How about the security aspect of things, right? Who hasn't had those considerations and have to make sure that our systems are secure? Our customers and their essence is the most important thing to us. It keeps us alive. That's why we're in business, is for our customers, to give them the ease of use and the assurance of insurance. But we have to think about it. What connections are you making? Where do you see something? What's missing in that field of data that would be interesting if you layered it on top of it? There's a military strategist. I love this man, Mr. Boyd. He affectionately thought through something called an OODA loop of observe, orient, decide, and act. When we think about data, it is a process that if you can operate through this with speed, you win. That was the whole premise of the strategy. Operate faster, cause uncertainty with your opponent, and go faster and win. It starts with observations, right? So with data, right, we need to have data owners. Data is a product. It's a thing of value. Treat it as such. Observe it, understand it. What's it? How is it structured? Is it structured? In my world of system data and metrics and machines, a lot of that stuff isn't structured. So we have to go and apply something to it. We have to orient ourselves to that data and understand it. This firewall data, that router data, this application data, it's not looking the same. We have to find a way to bring that all together, understand it, take some time, orient ourselves to it so then we can make those decisions. How can I visualize it for an operator to know this is the action to take versus another? How do I give them the knowledge and the confidence to pick up the phone at 2 a.m. and call the DBA and not the DBE? Database admin, database engineer. The alphabet soup of acronyms. Kills me. But John Boyd's OODA loop, it's great reading. I encourage anyone to look into it more. But if you want to start to think about strategies and patterns of decision making, this is a great one. And when I think of data and making decisions operationally with a lot of things, you have to know what to cut out. You have to understand the systems and observe a bunch of different inputs. And the faster you go through this cycle, the more success that you will have. So, kind of quick, going through a lot here tonight, but I want us all to think about this call to action. This visual is from an O'Reilly book on the fundamentals of data engineering, if it looks familiar to you. It's a great read. I've gone through it once only, but it was good. And this picture really stuck out to me when I think of my own platform. What we do at our space in monitoring is we collect data. We collect it, and that's that ingestion piece, and we have to put it somewhere. Storage sits underneath it, but that's not good enough. There's some transformation. There's serving it back up to those other systems, the analytics system, the ticketing system, the automation system, right? We restructure it and spit it back through the system to further refine it. We simplify it. We give it to customers so they now have a product they can use that's a little bit easier to understand than just looking at the raw bits and bytes of data. But if you start to think about that, and then think about what John Boyd tells us with an OODA loop and decisioning and plan, do, check, act, right? Orient, observe, decide, act. Those frameworks of getting you to motion. It starts to get you to that place where you can take something that's really, really, really hard and simplify it down and start to take actions. And they're not fast. It starts slow, but it starts with one. And you repeat it, and you repeat it, and you do it again, and you go faster, and you go faster, and you learn more, and you add more. And that is really the value of thinking about your data in this way. Why we have to do that, just to really highlight this, this is an image that speaks a lot to me. If anyone's going through those conversations in refactoring, right, we have these great applications built in this way, and they served businesses extremely well for a long time. Things have changed. The earth has changed underneath a lot of development and a lot of technology, and now we went from the left to the right. But not only do we go from the retain and optimize with those legacy systems to the image we went through earlier, we're way over here on the right with cloud native stuff. Everything's an API. I don't know where it's going. Azure, AWS, my own data center, John's computer, because I actually have my code running there and it can still talk to it. Like, we don't know where it's going, but when we rethink about this and we add all these layers of complexity, we have to be thinking about different ways to orient ourselves, observe the data, orient ourselves, make decisions, and act. We got to keep on going at an ever-increasing speed if we want to keep up with our competition. Going through that process, so I want to leave with a few benefits that we've seen, that we've realized. They'll be soft, but again, I'll talk to anyone who wants to know more about any of these things. But the ability to make decisions faster. A lot of times we have customers that do and operate and manage their system data internally to themselves. Right? Think of that engineering team, that platform team, and they're the ones who get caught on the bridge to make the fix. What if that data was available to other people, your incident commanders? What if it was available to the application developer? What if they knew how to get to that data? Could you go faster? Could they make a decision quicker? Could they save your call in the middle of the night and actually call the right person to solve the problem? Automation is a huge topic in my circles, right? I think if we did a poll in the room, everyone has probably heard of automation solutions. There's one that's in the news all the time. If you think about automation in artificial intelligence and getting the toil reduced from humans, right? That's really that's the promise. Data is your key into that. And your operational data, that's what's going to do it for you. Because it's consistent. It's consistently good when things are good, and it's consistently bad when things are bad. So you know when things start to drift. How can you take that drift and take an action from it? And maybe it's not go ahead and call the API and do the thing or roll back code. Maybe it's not that extreme. What's your first step? Hey, pull this search. Grab these data elements. Help me understand. Build confidence. Trust that the data is going to be accurate. Once you have that confidence in your data set and the quality there, you can start to automate. And that's how you start to get the speed. You hear the companies that are really pushing the AI ops and the automation aspect of things. It comes with quality data that you understand. And it's not looking at the event that you think you know. It's looking at the anomaly that you didn't expect. And then training it to understand what to do when that's done. To get to that training, that automation, right, the final benefit here is something that I think we all have to do as admins, as architects, as planners, as designers, as developers. We have to know that this automation, this intelligence is actually getting us more intelligence. It's helping us be able to focus on the things we need to focus on versus the toil and the mundane. I don't need to restart IIS one more time. I don't need to add disk to a server one more time. I don't need, right? We know how to do these things. Let the systems do it. Let your data help you in that journey to get there, to then share the knowledge and grow. Then you can focus on the next base thing. How are you going to move that monolithic application in your data center to the cloud? Any questions? That was a lot. It was fast.
mentioned customers. I will admit I'm kind of ignorant about, aside from the insurance part, but what other customers does Progressive have to serve? And how do you use some of the data to serve them?
Can you repeat the question?
Yeah, that was a great question. So the question, and if I get this wrong, feel free to correct me, but it really was around how do we use the data to not only serve Progressive customers, but what other customers are out there for us? And anyone operating in a marketplace, Progressive operates in the United States. Who are my customers? People in the United States. That's for the Progressive view of it, right? Now, if I look about it more locally within my domain and my space, I'm an internal IT domain. I serve the business. So if the business wants to operate or get some insights from their systems and data, that's who my direct customers are. So when I think of customers, most directly in my day-to-day work, I think of those people at Progressive. The almost 60,000-ish of us, give or take, a couple thousand maybe, of people that from the claims rep out in the field servicing somebody to making sure that that system boots up fast. I can't do much, but I can make sure the data's there so that field engineer can troubleshoot their endpoint. So that when I think of the customers, like it's really who has the need, and that's who we want to serve. Does that help? Yeah.
What are the biggest limiting factors to either real-time or getting to the data that you're looking for?
So the biggest limiting factors, and only have 20 seconds left, so we'll take this question and we'll wrap it up. Getting to the data is the biggest limiting factor in understanding it, right? A lot of folks know what the systems are and they've engineered it, but not as many have looked at the data that they produce. That is the biggest from a real-time aspect of it in getting to it. So when I go to ingest it and source it, if I don't know I'm pulling in good data, it's going to be bad data. But we can talk more later if you want to go into that one. Thanks.
Really good stuff. Really good stuff. Yep. I'll hold that for Steve.
Well, that was great. While we're getting hooked up, I remember in a previous role, I managed a team that was responsible for our e-commerce site. And one of the things we did was we queried our JBoss server log for errors. And then we joined it to our web server logs to figure out which errors were costing us the most. And I mean, it was incredibly difficult to do. I'm sure the way you guys are doing it is so much better, but that data was so valuable. So I really appreciate operational data. That was awesome. Okay, so I've got to dial into the Zoom, correct? Yes. Am I dating myself when I say dial in, by the way?
Very much so.
If your computer makes the sound,
I will say it
then you're
till I suck my last breath. I will say dial in. Yeah, exactly. And I need to turn off the mic, right? Okay.
I made that mistake.
I will not hit the end button either, thanks to Jonathan's prescient advice. Which one is this? There we go. Okay. So my son is a data analyst at
I'm not seeing the slides. I don't think you shared.
oh, I'm sorry. I didn't share. You're right.
Quality control, baby.
No. All good. Please call it out. I appreciate it. There we go. Is that better?
Yep.
Okay. My son is a data analyst at Safelight. And I asked him, knowing I was going to have this talk this evening, I asked him, are you guys using data mesh at Safelight? And he said, never heard of it. So I thought I'd start. Who in here has heard of data mesh? So 35, 40%. How many of you could give what you would consider to be a reasonably simple explanation or definition of what data mesh is? Okay, so we got 2. Good deal. So this is perfect. Okay, so as you can see, I'm Steve Howard. I'm a staff solutions engineer for Confluent. So we are here this evening to talk about data mesh. If we can get our... Oh, and how do I do this? Just hit, is there a start button up here?
Yeah, right on the right.
Oh, there we go.
Yes.
Yeah, exactly. Operational data. If it's not been clicked in some period of time, then turn it on.
Well done.
I'm going to see. Oh, I know why this isn't working. Oh, there we go. Okay. So some housekeeping. If anybody wants to take a screenshot of that, just some QR codes for a variety of resources we have. Current is our annual conference that's coming up in September. So take a screenshot of that as well if that's something in which you think you're interested. That's a really, really good conference. But I know I've got 20 minutes, and I'm historically really bad at managing time. So we are going to take a whirlwind tour through data mesh this evening. So what is data mesh? So data mesh is not a product. It's nothing you go out and buy. It's a set of 4 principles created by a woman by the name of Zhamak Dehghani from ThoughtWorks. And it came out about probably 5 years ago. It is a pattern. It is nothing, again, it's not a product. You don't go out and buy a data mesh. It is a way of approaching managing your data architecture. There are some elements of it, such as data marts, domain-driven design, microservices, event streaming, things you see in other architecture patterns that you'll see as applicable within data mesh. So what are the 4 principles? Number 1 is data ownership by domain. So you can see here that we have these, kind of these islands of data. We have inventory, we have shipments, we have orders. And then up there, of course, you see our little domain members as well as a data product. So let's talk about what that means. So domain-driven decentralization. Ensure data is owned by those that truly understand it. This is the first core pattern of what data mesh is. Historically, we've had a data warehouse, and I've lived this life, where you would have one big data warehouse. You would have a centralized team that was responsible for ingesting data through daily, perhaps hourly, semi-hourly feeds. And they would have intimate domain knowledge, or as much as they could, of things like inventory, shipments, clickstream, these different things. And they would aggregate and roll up via joins, counts, aggregates, all these different things for these reports. That was a heavy lift and continues to be a heavy lift for that team. The pattern of data mesh advocates having decentralized data ownership. So you really have this idea whereby something like inventory or shipments or something like that, that data is actually owned by that team. One of the quotes from Zhamak is, instead of collecting, you want to come up with a model that allows connectivity of the data. So the data lives wherever it is, wherever it's produced. We'll see shortly a data product is created from that data and then exposed externally. But again, the thing on which to focus is that domain-driven design, domain ownership. So a practical example is we've got Alice. Alice runs our order data system for us. There's an orders database, there's a shipping data database, and then we've got Joe. Joe runs our inventory system. Joe handles things like billing and recommendations and inventory. And what we find is inventory items are going negative because we have bad order data. He could fix that data up locally because Joe's really smart. Joe knows how order data works, and he could go ahead and get on with this job. But what he should do in the data mesh design is he should go to Alice, who runs the order system, and get that data fixed at its source, and then have a means by which he can extract the fixed data and load it into his system. Alice needs to be, to make that work, she needs to be a responsible and responsive data product owner, which is the next principle we'll see. So data as a first-class product. So you have this idea of a product manager. And normally when you think of a product manager, you think of something like Procter & Gamble or something like that, like a consumer products company. But in a data mesh architecture that you implement, you actually have someone who has the role to be a data product owner. So what does a good data product or a product owner in general do? Well, they evangelize, they understand customers' needs, they ensure that there's a product available that meets those needs. They understand their users' requirements, they understand the capabilities that are needed, and they build a product that does that. And I love the phrase, it's important to prevent data chauvinism. So that's this idea, and again, I've lived this life where I came out of retail before I came into Confluent. And you would have your merchandising applications and your commerce applications and all of these different domains that created their data for their own uses. And anything that you got out of that in a data warehouse was almost like exhaust. It really wasn't looked at as meaningful data. It was just kind of like, okay, this is what we've sold, this is how many, this is what we charge. You guys do with it what you want. again, that centralized team ended up having to have intimate knowledge of the data to make that clean in a format that was consumable by the downstream consumers. So a data product is really just the idea that it's a node on the data mesh. Because again, if we think back to that quote of the emphasis should be on connectivity of the data and not collecting the data in a single place. So what we should be looking at are things like, high quality data within the mesh encapsulates all the elements required for its function. So you actually have a team, and again, we'll take this example of orders, where they would be responsible not only for this application that processes orders, but also emitting data in a product-focused way that understands, if people need order data, they need to understand what the product that was purchased was, how much was sold, how much was charged, all of these common elements, and they would expose those as something that anyone that needs would be able to go in and fetch. They would also be responsible for the code and the infrastructure, and we'll see why that's important shortly. So that connectivity within the mesh itself lends itself naturally to event streaming with Kafka. And this is really the key thing on which to focus. So rather than having like databases and things like that, where all of these different domains that need to consume order data need to reach in and understand what that product is, we would have our orders database, our order data product, that would simply emit events as order changes occur, as they're submitted, as they're processed, as things are added to our cart, as they're removed from our cart. Those events are simply submitted into a public API, is what we'll call it, that allows other users to consume those changes. Now, this is a logical view, not physical. The reality in Kafka is often better, depending on how you configure your clusters. And by the way, this is not a Kafka 101 tonight. There's some assumption that you understand what Kafka and event streaming is. But if not, we can certainly talk about that afterwards. So event streaming is pub sub. It's not point to point. This is probably as close as we'll get to Kafka in a 101 format. So you have this idea of this data product where you simply publish your order change, and you publish that to Kafka. And we'll talk about some different ways you can do that. And then you have your other data products. It might be an analytics system. It might be a machine learning system to figure out recommendations, product recommendations, that kind of thing, that are simply consuming those order events, and then perhaps they're creating their own data product from this. Now, there can be, and one of the things I probably should have touched on earlier, again, is this is a pattern. So the data warehouse, by the way, was not a bad idea, to be clear. The data warehouse is not a bad idea. It's just that this is another way of doing this, and in some ways this makes sense. So you might have a situation in which you have domain level expertise, you have enough technology expertise within each of these teams to expose these data products. In other cases, you might find in a simpler format, matter of fact, I was talking with someone just before this, who was using Spotify as an example. The fact that you've got a song, a user list, and that's usually the example that's given for things like a data mesh. In a more complex organization, you might find you still stick with the data warehouse. We don't have any really perspective on which way you go. If you do a data mesh, this is a way that we think you can be successful. So why is event streaming a good fit for meshing? Just go a little bit deeper on this. Streams are real time, low latency, so you propagate the data immediately. That's absolutely key. So again, as those orders come in, as those product changes come in, as customer changes come in, you are publishing those immediately into a topic within Kafka, and then you have other data products that are interested because they have something they need to know. It's an analytics, again, it's a recommendation engine. And they need to know, okay, this customer just bought this or just looked at this in the clickstream, so I'm gonna surface this to them. But you publish those events in real time. Highly scalable. I just did the math on this the other day. It's still shocking to me. LinkedIn processes 87 million events per second through Kafka. 87 million. Now, most organizations in here probably aren't doing that many events, but anything like that, that you would even come close or even not close, scale is not an issue. Streams are stored and replayable. This is absolutely gigantic. If you have a data product and you're consuming orders, and again, we used the example earlier of there's a problem in the order feed, how do you go back and really fix your data? if you have it in a database? Do you say insert into my order copy as select from orders database or timestamp greater than tonight at midnight? Or do you simply replay the event stream and you get the breaks in there, you go back to the start. You get the broken data in there, but then ultimately you get the fixed data as well, and you have this complete current picture based on the event history. Streams are immutable. So it becomes an auditable source of record. Again, you can look back at an order or a customer or a product, whatever it is that's changed, and you can ensure that you have the correct data. They're addressable and discoverable. That is key criteria for mesh data, and we'll see why that's important shortly. And popular for microservices. You're probably already writing streaming if you have an event-driven architecture. So this is kind of a natural extension of that, just in the analytics space. So how do you get data in and out of a product? This is often the common question, and it's totally fair. So you can do this with a continuous stream, which is what we think is a good approach if you're going to build a data mesh, have a data product where you're emitting your events into a data product that other systems can reach in and simply consume those events. You can do something like a snapshot via a request response type API, or you can do a snapshot via nightly ETL, which is what most folks are probably still doing. That's the path of least resistance because it's the way we've done it in the past. We think that there's value to be seen if you use Kafka connectors. So a connector is exactly what it sounds like. If you have an external system like Salesforce you might consider a data product because you may have a CRM team that's responsible for that, curating the objects, the structure. They may have something where you can go in and simply fetch those changes via like a CDC type tool, which we have as a connector. Same thing for Oracle or any number of systems. By the way, the internals of the team that is responsible, again, we'll go back to our order system, we shouldn't care. That should be agnostic what that solution is. If that's a Mongo database, if it's Apache Pinot or Druid or any of these, if it's an S3 bucket, it really could be Kafka, it could be anything really. How the domain team solves specific problems internally doesn't matter to other domains. All they do is curate and publish data that they know intimately, because again, think about that domain ownership. Then they curate a data product for other teams to consume. But the team that's on the inside might want to use something like stream processing. So stream processing is this idea that as you are publishing orders and things like that, you may want to roll up account by card ID or something like that. You might publish that topic as your public interface to all of these other systems, these other data products that are looking to consume your changes within the data mesh itself. And I'm going to move a little bit faster. Could I get a time check? Oh, good deal. Okay, I'm doing okay. Okay, so finding data products. So you have to be able to do that, right? So you need some kind of registry or something that allows you to do that, to go in and look at orders, payments, shipments, whatever it is, and to do that data discovery, because that can be hard to understand. The other thing that's key about this is data lineage. You have to understand where the data came from. That's what usually makes this so difficult. So you have this idea that you have orders that are produced, and then all of a sudden you've got 100 other systems that are consuming that, and they do something with that order data. And then all of a sudden another system maybe consumes that. That goes back to, and I think we've got a slide later where we talk about the law of Demeter. And if you're not familiar with that, it's really this law that it was based on a Greek goddess that really was this law that you really shouldn't exchange information much past, the person, your neighbor, because it gets too diluted past that. But you're going to find that over time, you're probably going to have some data products that are aggregated. So you might take customers and orders and join those together out of the order system. And then all of a sudden, if something's broken, it's like, well, where did it come from? That's where data lineage becomes incredibly important. So what's our third one? Self-serve data platform. So we've had, just to go back, we've had domain-driven decentralization. So there's this idea, if you picture your organizations and you have 10 different domains, and by the way, those can roughly line up with microservices. So if you've refactored your organizations and said, listen, we need 10 different microservices. We need one for orders, inventory, customer, product, all these different things. Your data products in a data mesh, similar to a service mesh, and that's not an accidental naming if you think of solutions like Istio, where you do have a service mesh. those kind of domains would line up with what you do with a data mesh. Again, it's just on the analytics side of the house. I often find that helps folks reason about it a little bit more. Oh, thank you. I ask my partner to give me time checks because, again, I'm usually terrible about managing time and this kind of thing. But so why self-service matters? So you have this need to have this self-service data platform because, again, otherwise you get into this position. These kind of build on each other where you have domain ownership. That one's usually pretty easy. I run orders. I understand my orders database. I'm going to put out there what I think is usable for other people, and there it is. And I can even do a data product. I might go out and interview some people and be able to say, what do you guys really need? What are you looking at doing? And build a product. But for them to get to that is what is absolutely, and somebody even asked that question of Jonathan earlier, is how do you identify and get to the data, collect the data? That's always one of the key questions to ask, right? Especially in complex organizations. So this is a real life example. You might have data from 13 sources for a trade surveillance system in like a capital markets type of solution. Some sources publish events, and this is the other thing that gets messy. You have all these different domains that do data differently. Some do MySQL, some do SQL Server, some do Kafka, some do ActiveMQ, some do batch files. In this case, they needed both historical and real-time data. Historical data from database extracts were arranged with the dev team. The format of events were different to the format of the extracts because over time you have things like schema changes. That makes that really, really hard if you think about it. I mean, I remember when we had data warehouses, we had Teradata, it took months to get change requests through because you would break things, you had to go back, you had to replay historical data if you had it. If you didn't, often you just truncate it. It's like, well, we don't have that anymore. It took 9 months of effort to get 13 sources into the new system. Does that sound familiar to anybody? So making domains autonomous in their execution through rapid data provisioning. And this is not a UI that we have, but conceptually, this is what you want to look for. You want someone to be able to go in and immediately find orders and customers, and they may say, you know what, I want to put that in Elastic and Lambda. That's kind of our conceptual flow. So below, they might check orders and customers. They may say, yeah, I actually want the historic data for customers because I want all of my customers, not just the most recent orders. And then over time, I'm going to begin extracting and curating the customer and order record together. And I want to send that to both Elasticsearch and AWS Lambda. That's the kind of the logic behind it. That's a picture that hopefully gives you an idea as to what that might look like. So consuming real-time and historical data from the mesh. I am going to move a little bit faster. Hopefully that's okay. And by the way, if anybody wants to talk about this afterwards, I love talking about this. So the last one is federated governance. So we've had domain-driven decentralization, data as first-class product, and self-serve data platform. So federated governance is this idea, and this is the hard one. This is the hard one. So this is this idea that you have to have this overarching governance team that will actually keep this at play, keep it working. Really what it boils down to is it says here, and again, I'll probably have to take this offline. There's no silver bullet, but the thing I'll say practically you want to focus on are common join keys. Those are absolutely critical. So things like customer ID, the order ID, things like that you can scale. You don't want to put a bunch of business logic in a data product that's downstream from the upstream original producer. That's where you get yourself in trouble, generally speaking, with a data mesh. But again, there is no silver bullet. What's decided locally by the domain versus globally. But what you definitely want to have is a tool that allows you to track this. And I think we've got something in here. So data lineage. You want something that's able, like here, you probably can't quite see that because I can't actually. But you can see here, you've got stocks, you've got these different topics and these curated streams that are kind of rolled up. And then you see some connectors coming out of that. That lineage is critically important because if you're building a product, number one, it lets you know where do I get my data? And number two, can I trust this data? Do I have a good data product owner? It's owned by the orders team. They're a good data product owner. This is how it's flowed. I can trust this data. Data lineage is absolutely key. If you take nothing from this talk, take that. Data lineage is key to understanding a data mesh. Otherwise, it gets very confusing very quickly. And I've got 30 seconds, so those 4 principles. So the easiest one, honestly, they kind of go in sorted order, to be honest. Data should have one owner. That's an easy one. Data is your product. You should be focused on good data. and you can access data anywhere immediately and painlessly, historical or real time. That's difficult to execute generally. Governance helps with that. I would advocate, if you're interested in this, and I honestly, 100% honesty, I think this is a great approach. I'm just going to turn that off and keep going. No, I'm kidding. Is that demo link. That's a really, really good demo. And actually, I think there's even a link in there where we'll give you like $400 of free credits if you want to try that and build a simple data mesh to understand these concepts. Really, really good stuff. So hopefully that's helpful.
Can you go back real quick?
Sure.
I was trying to.
Oh, yeah, no, absolutely. Sorry, I know I'm going quickly. And this is another good one as well. Does anybody want that previous one, or did everybody get it? We could distribute the deck, I think, too. Yeah, so thanks for your time, everybody. Yes, swag out front, thank you, Derek. And also, I do want to thank Doug and Jeff and the whole Progressive team, really. These meetups are great, and I am getting out of here, I promise. These meetups are great. I appreciate so much people coming out in the evening for this, because I know that all of us would rather often be at home. But it's always encouraging to me personally, to be honest, that people come out for these. So thanks a lot.
Thank you.
I think that's it.
Alrighty, and the last up is me, and I'll be straight. I'll be straight. This is a bit of a conflict of interest, though, isn't it? Let's see. Let's see, and then, oops, oh, come on now. There we go. Oh, no, wait. Swap displays? Oh, wait, no, oh, I have the right one. Okay, good. Does everything look okay on the Zoom? Do you see the right thing? Oh, yeah, that's what I was afraid of. What do you think? Swap displays? Mirror. Better? Ugh, that's not good. That's worse.
If you just stop sharing and then swap displays back, you should be able to share the application itself.
It looks like, are you good? Okay. Excellent. This is like a backseat driver with like 40 people. Okay.
It says your screen sharing is paused.
Oh, no.
Resume share. Green triangle. Green, go up to the ribbon.
Where's my, shoot. I don't. Where is the? Okay, so far so good, yes. Screen sharing.
Yeah, restart the presentation.
Are we good? Let's go with this. All right. Okay. Thanks, everybody. So this is a talk I did a couple of weeks ago at Miami University in 30 minutes, so I've got 20 minutes this time. So we'll skip my background. So the main thing here to focus on is I've been doing a lot of hobby writing during the pandemic for the Association for Computing Machinery, the ACM, not the American Country Music Awards. Just to clarify that for anyone. Plus also I did one post on for hymns as well last year. So let's start with the ACM post. So why are there so many programming languages? So I wrote this last year. This was published July 2022 on the communications of the ACM, the blog site. It had been the inspiration went back decades. So I was talking to a friend of mine back in the early 1990s who was a lawyer. I mean, everybody has to know at least one lawyer, right? Just talking, and he said, why are there so many programming languages? Why isn't there just one good programming language? And I thought about it, and I went, that's a really good question. And so I answered with like, well, you know, different languages are designed for different purposes. And I was really, I knew it was sort of right, but it also, it was incomplete in a way that I just, and it stuck in my head and it bothered me for a long time. And so, and when you think about it, like, and this is the programming paradigms, right? You ask like 10 people for different paradigms and you're going to get 20 different sets of answers. So there are at least a few of them, you know, procedural languages and functional languages and declarative languages and object-oriented programming languages, and then everyone's favorite multi-paradigm, right? Which is basically where everyone turns into the other language. And so it's a grab bag. So it kind of makes sense that there's not one language, you know, but how many languages should there be? I don't know. So taking some advice. So another one of the posts that I wrote, which was how to write. It was a meta post on how to write for the ACM blog, and one of them was like that. One of them was the idea list. So keep track of ideas. So I was usually always working on a primary, and then I had a secondary that I was working on, and then I had a whole bunch of other ideas that were like, this seems pretty good, but I'll get to it later. And then at the very bottom of the list was why there's so many programming languages, because I knew I wanted to write about it, but the topic just seemed so big that I wasn't never going to get my hands around it in any way that would make sense. But I had this one picture of a visit that I had in my head to the Computer History Museum years ago. I had that in my head. That's actually on the wall of the history of development languages. It's a big picture of a sample of programming languages, and it's almost fractal when you look at it. And I had that picture in my head, and I wanted to use it, but I couldn't find it online. So I asked. Don't ask, don't get, right? So I asked the museum, do you have this online? Is it available? And they said, they got back to me pretty promptly, and they said, no. And they said, thank you for asking. And then I went, oh, rats. And so, but about 2 months later, they got back to me and said, thank you for asking. Your question prompted us to realize that graph ended at the year 2000. And we haven't updated it in about 20 years. And oh, by the way, here's the original PDF. And stop by the museum sometime. We'll give you a free tour if you're ever around. And good luck on your article. And so this is a section from 1954 to 1971. And again, like I said, it's you can spend minutes, a long time just tracing your finger back and forth looking for influenced edges. So with that, I knew how to tell the story. And so I was using the graphic there on the right to help tell the story. Now I know everyone that writes is always writing, for purity of heart and for no motive other than that. So for those of you that know some more shallow people, who like to brag about the fact that this page is actually on the first page of Google results for why there's so many programming languages. Tell those friends. I know you don't care about it as this audience, but if you know people that are impressed by such statistics, feel free to drop that trivia. So again, it was a good exercise, a lot of fun. But then I realized after writing that the rabbit hole only, like I was at the very beginning. The rabbit hole just kept going way, 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 way deeper. So why are there so many programming languages and where do they come from? So at the left-hand side of that chart in the museum, it has this this qualifier. This chart shows about 150 of the thousands of programming languages that have been invented. So how many languages are there? However many languages you think there are more. So that was a subset of all the languages that existed. And so one of the nice comments that somebody posted was this guy named Paul McJones, who I didn't know him before he posted it. It turns out he was a researcher, a language researcher and developer from the 60s and 70s from IBM Research and also DEC Research. And he said, oh, by the way, you should look at this ACM paper from the history of programming languages. And I went, wow, because I knew I wasn't the first person to have this thought, but I didn't realize how far back it went. So I looked at that paper from 1978. There was a history of programming languages conference, and at the beginning of that was this graph. Does that look familiar? So that was a chart from 1972, and less than 20 years since the advent of the first high-level programming languages, people were already trying to ask, why are there so many programming languages? And so the link is there for anybody that wants to look it up. And so these were the categories. Remember how procedural, functional, declarative. So these were the categories. So I didn't change the descriptions. I just made them bigger for readability. The categories in the swim lanes were numerical, scientific, online, non-numerical, scientific, business data processing, string and list processing, and of course everyone's favorite, multi-purpose, and then experimental and others. So that's how people were trying to get their hands around language purposes. Now it went back even further. So this book, anyone read this book? This is from 1969 that covered 120 programming languages in 1969. And that was selective. Like she left languages out. And so that name, Jean Sammet, should be important because she was actually one of the initial COBOL developers. And we're going to get to some of that history also. So this is a quick overview of some selective languages. So this is my favorite. What's in a name? And I used this joke in the post. Fortran, Comtran, Basic, Lisp. The greenfield languages had the advantage of being named for exactly what they did. Formula translator, Fortran. Commercial translator, Comtran. Lisp processor, So I think on the right-hand side they missed an opportunity. COBOL, ALGOL, Snowball. So Simula was actually considered the first object-oriented language. I think they should have called it Objol, because they would have had a clean sweep of OL languages on the right-hand side. So let's take a quick look at the Fortran line. So again, this is a directed acyclic graph. These are major influences. It's not a tree. It doesn't mean that there was only influenced by one. So these are considered major influences. Is everybody? Oh, and the other thing was after getting a tour, I got a chance to actually go to the Computer History Museum again and meet with the senior curator, the guy that gave me the PDF. He said you have to be very, very careful in museums with the F word. Very careful. That word is first. Very, very careful when you say something is the first something. So there's always a qualification. There's always an asterisk. It's like the earliest known, first known, and it depends on how you're bucketing things. So Fortran is considered the first mainstream high-level language. It wasn't even John Backus's first high-level language, for those that know the history. This was just the first one that went mainstream. And there's also a little bit of blurriness in the dates. Do you date a language from when the language spec came out? Do you date it when the compiler came out? Sometimes they're years apart. So again, give me some a little bit of slack here on the dates. So the interesting thing about the Fortran line is the major descendant of Fortran asked 3 completely different questions. Fortran was, wow, high-level languages are great, right? Basic said, high-level languages are great. Can we make this easier? The Algol said, high-level languages are great. Could you make them more powerful? And the CPL line said, high-level languages are great. Can we make them a little lower? Because this was all system programming. So because the alternatives were what? Assembler, right? So some quick trivia. Fortran, again, not the first high-level language, but the first mainstream high-level language for scientific computing. Algol, huge influencer of later languages. Code blocks. Call by name, call by reference. Like, these are huge concepts that were introduced in the late 50s. Pascal was supposed to be, Algol ++, basic, again, that was easier. Simula, considered the first object-oriented programming language, supposed to be an extension to Algol, wound up being something unto its own. So this I love. So CPL, BCPL, B, and C. I mean, everyone's heard of C, right? You probably maybe haven't heard the prior languages. So, who's a Java programmer? Curly braces? Exactly. Didn't come from C. It came from actually BCPL. Curly braces are entered the, and the // comments that didn't come from C++, that came from BCPL. So this was a difference, the BCPL and B. So in BCPL, when that compiler development was taking too long, what'd they do? Start over again, of course. So that's where B came from. They were like, can we make this simpler? And so they stripped on the language spec, created B, and then B begat C. Which then basically became the dominant language in systems programming. COBOL. So you're obligated to say Grace Hopper 3 times, or else she'll come back from the dead and steal your bitcoins or whatever. I mean, a lot of interesting history here. So notice that COBOL actually was predated by 2 languages. Comtran. Now notice the similarities. Comtran, Fortran. IBM's first, remember, Fortran was for scientific. Comtran was supposed to be COBOL. That was supposed to be the commercial translator. There was another system called Flowmatic. That's actually what Grace Hopper built. And so you had 2 languages that were both aimed at business developers. So COBOL was actually designed by committee. Does anybody know this? It was not designed by IBM. As a matter of fact, there was a lot of anti-IBM bias in the process. So there was a part of a Defense Department initiative to create a portable language between machines. And so, yeah, when you think COBOL, right? What do you think? Mainframes, Grace Hopper, stuff like that. It was actually designed by committee, and it was a merging of ideas that were from Comtran and Flowmatic. Although the wordiness did come from Flowmatic, back when Grace Hopper was at Remington Rand. This is my absolute favorite language case study, PL1. So who's heard of PL1? Anyone? Excellent. So PL1 was the collision, oops, did I say that out loud? It was the, between Fortran, Algol, and COBOL. So in 1964, IBM said, we got too many languages. Now remember, this is 10 years since the advent of the first high-level programming language. And already IBM is like, we have too many. We've got, the name says it all. PL1 stands for Programming Language 1. This is supposed to be the Highlander of programming languages. So there's not supposed to be a 2, 3, or 4. So they wanted Fortran scientific computing, COBOL's data processing and report writing and overall business usage, and then Algol's complex language features. So yeah, and this was actually, unlike COBOL, was actually created by IBM. So yeah, within 10 years of the first high-level programming languages, now we have too many. We need to start over again. It goes way back to the advent of computing. Simula. Simula is a huge, this is again a subset of the object-oriented languages. Simula was a huge influence on Smalltalk from Xerox PARC, which then generated C with classes, because remember C from the prior slides, which then generated C++, which then generated Java, et cetera, et cetera. C++ ultimately was an object-oriented extension to C, and then Java was like, wow, this is really hard. Can we make it safer? Lisp, any Lisp fanatics? Everyone's seen the XKCD here about the these are your father's parentheses for elegant weapons for a more civilized age. Lisp, Reduce, Logo, Scheme, those are all basically Lisp-based languages, and quite amazingly, like Lisp has a very fervent fan base, 50, 60 years hence. Commit, who's heard of this? Snowball, my absolute favorite named language. Who says they don't have a sense of humor? So Commit was the first string processing language, which begat Snowball, which begat awk, which ultimately a lot of those features wound up in Perl. So when I came across Snowball in my language research for my post, and I threw it in just because it sounded funny. And Paul McJones, actually, the guy that commented that in privately, he implemented one of the first Snowball compilers. And so I was like, I respect it. I respect your work. I am not making fun of it. So he took it in good humor. So why? There's a lot of languages. So we talked a lot about the that. There are many languages. Now, why? Here is a hypothesis. So I think I put this in the post, there are two drivers. There's control and fortune, and then you've got total design control. Java and C# kind of fall in that, well, initially it was total design control, and then it turned into a fortune issue. When Java started, found a sweet spot in the back end. Java was built for portability. Microsoft was like, I don't like that so much. Lawsuits, and then Microsoft created C# and then borrowed some other language features from other languages. So, it initially started as a total design control exercise, and then branched off another language due to control issues. Go, who's heard of Go? This is another, I think a total design control example. Google has its own containerized development environment. The Borg cluster, which led to Kubernetes, and they were frustrated with the complexities of C++, but they wanted better networking and concurrency. So they could have said, you know what, we like Java, but we'll implement a better runtime. Like, they could have done that. But when you've got like people like Pike and Thompson on your payroll, you're like, yeah, you know what, let's make another language. So if you have the use cases and you have the money and you have the time, then go for it. And Go is completely unrelated to Go, which was another language that came out in 2003. And again, if you're Google and you stomp on another pre-existing language, I guess you can do that, I guess. So so just showing though that the difficulty in namespace differentiation is getting kind of tough. So lastly, what was the Google of the old days? Bell Labs. What did they have? They had one of the biggest technical use cases in the world. They were running a phone system. And so a lot of their research was either for basic physics or for things to improve the phone system. So they had the use cases, they had the money, and they had the time, and they had the people. And so that's when you can come up with things like B, C, C++, S, Snowball, awk, among other things, Unix. So that's an example when you have that trifecta. That doesn't happen very often, but if it does, you can pull that total design control example as many times as you want. And with that, that's the brief tour on why there's so many programming languages, in my opinion. And for any other publications, there's the link. So again, I'm right at time. So thank you very much. Oops. Cool. And so for those that are online, thanks for coming. And again, for those that are here, thank you so much for coming. And again, spread the word about the meetup, and we'll be meeting again in July. So thanks, everybody.